Alright, so in this video we're going to take a look at a rational function that actually crosses an asymptote in a different way than the previous video. And so let's take a look at this one, 2x divided by the quantity x minus 3 squared. So first thing I'm going to do is I'm going to look for my vertical asymptotes. Okay, vertical asymptotes are when I've factored everything, right, and I've canceled anything that can be canceled. So this is completely factoring this. Let me just show that. There's that. Nothing can cancel, so now I take my denominators and I set them equal to 0. Well, I have x is 3. Okay, so that's my vertical asymptote. Let's take a look at the horizontal one. Horizontal one, well, this, when I multiply it out, is an x squared minus 6x, plus 9? And so I look at the unfactored form. Remember that on the steps? Unfactored form, and it's bottom heavy, obviously. And so if it's bottom heavy, my horizontal asymptote is y equals 0. So let me go ahead and put those two things on here. I've got a vertical asymptote at 3 and a horizontal asymptote at y equals 0. Okay, great. Now, let's take a look at symmetry. Again, you don't have to take a look at the symmetry, but it might be helpful. So, if I take a look at symmetry here, if I put in a negative x, does it keep the whole function exactly the same? No. So it's not an even function. If I put in a negative x, does it cause the whole function to be completely opposite, meaning a negative version of the function? No, it doesn't do that either. We could get into the details of it, but this one has no symmetry. We'll move on from here. So, let's now take a look at the x and y intercepts. X-intercept, y-intercept. Okay, x-intercepts. X-intercepts are when we make the y a 0. In other words, we take out the y and we put in a 0. So let's take a look. Do you notice it doesn't matter what the bottom of this is? The only time that I can have a fraction be 0 is if the top is 0. So I say, when will the top be 0? Oh, the top will be 0 when x is 0. So my x-intercept is x is 0. Okay, so there it is right there. Interesting, right? It's going through that horizontal asymptote. Okay, and again, we've seen that before. This one's going to look a little different than the previous one. The y-intercept is when I put in, when I put in a 0 for the x's and I solve for y. So I put in a 0 for x's. 0 minus 3 squared. Well, that's going to be a 0 on top, so it really doesn't matter what's on the bottom. As long as it's not a 0, then this is going to be 0. So again, my y-intercept is 0. So I have the point 0, 0 as both the y and the x-intercept. And the last thing I'm going to do is take a few points. Notice that I want to make my table very graph friendly. In other words, I'd really like to know what happens at 1, at 2, possibly what happens at 4, and maybe what happens at -1. So I'm going to go with -1, a 2 and a 3, and then a 4. Those are the values that I'm going to put in for x and see what happens for y. Here we go. I put in a -1. I'm just going to tell you what I got. I got -1/8. You can do the cranking out the values on your own. If I put in a 2, I'll get a 4. If I put in a 3, well, I can't put in a 3. That's silly. Because why? Because there's a no man's land there. There's a vertical asymptote at 3. So if I put in a 4, I think I meant to say a 4 and a 5, perhaps. If I put in a 4, then I get, looks like I get an 8. And if I put in a 5, I get 2.5. Let me go ahead and plot those points and we'll be through. So -1, I get -1/8. I get over 2, I go up 4. If I go 4, I go up 8. 1, 2, 3, 4, 5, 6, 7, 8. If I go over 5, I go up 2.5. All right, so it's not going to cross a vertical asymptote. Let me repeat that. This is not going to cross a vertical asymptote. So here's what I do know. I do know that this is going to do this. Now, if I gave myself some more points, you're like, how do you know that? Give yourself some more points and learn these graphs. That's going to do that. It's going to approach. As this x gets larger and larger, it will indeed approach the asymptote of y equals 0. Now, look what's happening over here. This is interesting. This one is going to approach the vertical asymptote, and it's going to come like this. It's going to be a smooth curve. Now watch this, though. I know that this can't go out. It has to go and approach as x gets to negative infinity, as x gets really small, it does approach the horizontal asymptote. That's a rule. You can count on it. So here's what I'm going to do. I'm going to go ahead and add another point to my table. I'm going to add a -2 and see what happens. So here's what I get. If I go to -2, I go to -4/25. That's really, really tiny. So what's happening is it's going down and coming a little bit back up, and then it's going to continue to approach that asymptote from the bottom side. It will not cross it again, but it'll continue to approach it as it gets very, very small, as x goes to negative infinity. Okay? I hope this was helpful, and thanks for watching.